So now we have Lauren's sprint, and you can see that we've got a series of times and displacements for Lauren over her first 5 metres of this sprint, and the question A is asking us to calculate the average velocity over the first 3 metres. Now if we're starting at 0 metres, and we might even want to fill in something like that to make it a little easier for us ourselves, and that's going to be 0 seconds. So the average velocity is the change in displacement divided by the change in time. So in this case the change in displacement from 0 to 3 is going to be 3 metres, and the change in time from 0 seconds to 0.96 is going to be 0.96, and therefore 3 divided by 0.96 is going to be equal to 3.125 metres per second. On to section B, where we're asked to use the first central difference method to calculate Lauren's instantaneous velocity at the 2 metre mark. So essentially that method is looking at the points ahead of and behind the time point of interest. So if 2 metres is our point of interest, we're going to be using the 3 metres and the 1 metre mark. And so again, velocity is going to be equal to our change in displacement divided by change in time. And you might want to use the first central difference formula specifically, but it's still essentially the same formula, again, just using the time points around. And so we're really going to be using the 3 and the 1 for displacement. So 3 take 1 and dividing that by 0.96 take 0.41. And that's going to give us a velocity of 3.6. Remember those are in brackets. 3.63 metres per second. Question C is also asking us to use the first central difference method, so we're going to use the same formula here, or the same method. Change in displacement divided by change in time, but this time we're going to be using around the 4 metre mark, the time point ahead, which is the 5 metre mark, and the time point behind, which is the 3 metre mark. And so 5 take 3 at the top, and 1.34 take 0.96. If you do all of that, then you will get 5.26 metres per second.